So we're going to talk about RamaLama. For those that just got here, you missed a lovely song, RamaLama Ding Dong, which is what we did. Eric Curtin came up with this idea last summer. Basically, it was all around running AI models locally. We kicked around a couple of names, and I said, I know a song from the 1950s called RamaLama. And Llama, because of Meta and Facebook, has become sort of the de facto name for open source type models. So a lot of people are using the name Llama inside of their projects. So I said, we'll just call it RamaLama. So RamaLama is all about running AI models locally. So really, there's two constituents of groups of people who would want to run models locally. So first of all, we're going to talk about the developers. So why would a developer want to run a model? Well, mainly because of familiarity, right? I want to run it on my laptop. I want to have it, all on my laptop. I'm on an airplane. I want to be able to run it. I don't need to worry about the internet or anything else. So, that's why I'd run it locally versus, say, a cloud version of an AI model. The next reason is simplicity, right? So usually engineers are going to be integrating existing applications into their AI models. So if I can build on my laptop and have the AI model running, I can really integrate. I can sort of watch what's happening on the model. I can watch what the service, how it's integrating. Whereas if I'm connecting to a cloud model, I'm not sure what's going wrong on it. And then finally, customization. So I can fool around with things like easily swapping out the model, try different models, try different ways to do it, maybe customize to get better performance. Things like that. So the other reason for the developer. On the organization side, the number one reason that people want to run AI locally or not in the cloud is data privacy. So it's all about data privacy and security. So you want to take your precious private data from your company and then share it up to the internet, to an internet cloud provider. If you trust them, that's good, but most people don't fully trust that environment. The next reason is cost control. We're waiting for it to get through the clouds over here. Did it show up? I'll just go on like the slides are showing. Cost control is the next reason. Anybody that's played with a cloud AI, you'll realize very quickly when you get the first bill that's incredibly expensive, and most AI models, of the open source AI models can easily run on a Mac. All right, in this case, I'm running it on an NVIDIA Fedora 42 system. So there are low-end devices and low-cost devices that you can actually run AI models on. And then the last reason organizations would want to do it is for regulatory constraints. Governments set up rules all the time that say things like your data can't be shared to a cloud vendor outside of your country or outside of Europe or something. Similar in the US, they have these laws called HIPAA laws, which are all around medical privacy. So if you want an AI to interpret, say, your x-rays, things like that, you really have to have tight controls on that type of data. So we talked about the tool of RamaLama, and our main goal with RamaLama is to make using AI boring, right? We want to, really with RamaLama is get the same experience that you have with Podman, where you could just say Podman run something. In this case, we want to be able to do RamaLama run. We want fundamentally to get the AI in containers. So one of the issues with people when they're sitting on their Mac and they play with something like Ollama or other tools and they run the model on their laptop, they get stuck on a Mac. Okay, so you get everything up and working well. Now you want to put it into production, right? You want to put it onto services that are running Linux, or you want to put it into something like Kubernetes. You're kind of stuck if you're running your AI on a non-Linux platform. So by putting the AI into containers, all of a sudden we're bringing in Linux into the environment. We want it to be registry agnostic. There's two main places that people are storing AI models right now. They're Hugging Face and Ollama. Hugging Face has a huge repository of models, and Ollama is somewhat smaller. But we also want to bring OCI registries. And again, what I'm trying to do is get people to move towards containers. So OCI containers or OCI registries, these are things like Docker Hub, Quay.io, Artifactory, things like that. When I put my AI into production, I don't want to have to stand up additional services, right? I already have a container registry sitting out there, so I want to be able to store my models, all my content or my AI content inside of those registries. We want GPU optimized. So one of the key things when people start to play with AI is they realize that they have a GPU, but they have to recompile all of the software. There's not one package that you can install on every laptop to enable AI. Each one of the AI inferencing engines has to be recompiled for your specific GPU. Most of you probably don't even know what GPUs you have on it. So one of the things RamaLama does is it goes out and figures out which GPU is and then pulls down a container image that is pre-compiled to your system to run the software to actually use the AI in a model. And then flexible, we want to be flexible that there is a whole bunch of AI model inferencing engines out there. Okay, the most common popular one in the low-end environment is a thing called Llama CPP, which we'll be demonstrating today. On the high end is VLLM, the thing that Red Hat is heavily invested in. But VLLM only works on real expensive GPUs, centralized servers, doesn't even run on a Mac. Can't even take advantage of a Mac GPU. And that's by decision of the upstream. The upstreams of Llama CPP is really concentrating on the low end, and VLLM is really, really concentrating on the high end. And that's, so they actually reject pull requests that try to change that. So a couple of months ago, DeepSeek shows up. Everybody here got all excited. What's this DeepSeek thing, right? The Chinese have jumped ahead of the US as far as AI development. So everybody goes out and they grab this huge model from one of the websites, download it, and run it as root on their system. And that's a huge AI model. You have no idea what's in it, and you're using a piece of software that you have no idea it's in. So I wrote an article back in February, just right after our DeepSeek came out, and said, you really should be running that thing in a container, right? So it's isolated from the system. It doesn't have access to your .ssh keys. It doesn't have the ability to compromise the tool that you're using for processing the AI model and really try to control what's going on. So we'll be showing you what we're doing with our AI models and the way we run them inside of containers. So RamaLama is built on top of containers. Basically, it's a wrapper around Podman or Docker. We used to really concentrate on this. Docker, we tried to work with Docker back in the fall on this project, and Docker has decided to go their own way. But as we've gotten further into more and more tools in RamaLama, we need things like pods to really get advanced. So you can actually run it with Docker. You can do all the simple stuff with it. But as soon as you get into the more complex operations, like using Llama Stack and things like that, we really need access to pods. So as I mentioned earlier, we pull the relevant container images to run depending on the GPUs that RamaLama discovers. The RamaLama team right now is managing a whole bunch of container images. So we have CUDA for NVIDIA, Vulkan is sort of the one for the Mac. We support AMD ROCm for AMD systems and Intel GPU. And then there's a couple of Chinese companies, like Khan and Musa. And then everybody that sees this is probably thinking, well, I don't have a GPU on my laptop. Well, it turns out they actually can do a lot of AI just with CPU. So it's a little slow, a little clunkier, but you can really get the feel of what AI is. And then, again, I mentioned earlier, we want to be able to deploy to OCI. So we would use the RamaLama command to pull something off of Hugging Face or off of Ollama and then convert it into an OCI image, something that looks like Quay.io/rhatdan/my-model. And you can push that up. And now, once it's up in that format, Kubernetes knows how to deal with it, right? Podman knows how to deal with it. Docker knows how to deal with it. So it becomes a content that's plugged into the CNCF world. We support multiple different GPUs, I covered those, and we also cover multiple different hardwares. Basically, we will run, because we run with container engines, we run on Windows, we run on Mac, and we run on Linux systems. And as I mentioned earlier, we also support CPU-only inferencing. So pretty much you can run RamaLama anywhere that you can run a container engine on the system. I also should mention that we're having lots of pull requests coming in from IBM because they want to run Z-series and Power series and things like that. RamaLama is a fully open project, which means we will accept pull requests from anybody as long as they follow the guidelines of the project. Olama, on the other hand, has not been so accommodating to open source. So that's one of the main reasons that we kicked off the RamaLama project. So an interesting thing that comes up is, which model should I run? So I mentioned earlier I wanted to run DeepSeek. How many people in here are data scientists? Okay, there's about 3 of you in here. Everybody else in the room, you probably have no idea how to figure out which DeepSeek you want to run on your laptop. So if you went out to Hugging Face and you said search for DeepSeek, you will get probably 20 or 30 different ways of that model sitting there. And you have to pick one out. There's things like 8B and 3B and different quantization values and all this stuff that these few data scientists actually know. But if you're a dummy like me, I have no idea. And what I want to do is I want the upstream or the open source community to go in and identify, for most users when they want to run DeepSeek, which one should they get? And so basically we have the concept of what's short names, which are basically name value pairs. If someone says DeepSeek, this is the one we're going to pull from them. Now you can override that and pull by URLs or other ways, but bottom line is you just want to do RamaLama run DeepSeek and get the experience. We mentioned earlier security, so we run everything by default inside of containers. Matter of fact, when you're just doing a RamaLama run, we actually shut off the network to the container, and we basically really try to lock down that container as much as possible. And we want to keep your data local, so you just, the only data that's going to get exposed to the container is stuff that you volume mount in. So things like the AI model, or eventually when we get to your database, RAG databases, things like that. We mentioned earlier that we allow you to choose your own you get your models from anywhere. And we also support multiple different model runtimes. Llama CPP is our default. Whisper CPP is a recompiled version of Llama CPP that allows you to do things like take that song I played earlier and actually get the words from it. So, if you want, we could do that later and everybody can get and sing together. And then you could swap out and use VLLM. We actually have OpenVino is available. So there's other people that are developing different ways of running AI models. We want to be able to swap them out. Similar to where Docker and Podman support OCI runtimes, we want to support basically model reference engines. The commands to run it are really, really simple. So it's RamaLama run and RamaLama serve. When you do a serve, the default for the industry right now is to serve an OpenAI REST API. So almost everybody that's building software is communicating via the OpenAI REST API. So out of the box, RamaLama serve will serve up a OpenAI REST API. And we're just getting to the point of supporting LlamaStack. So LlamaStack is a way to pull different types of services together in this common environment, and we'll talk about that a little bit later. Last thing to understand about RamaLama is we want to get you to production. RamaLama is a developer tool. It's not something that needs to be run in production. What you're going to run in production is the containers. So we actually have RamaLama serve -- generate, and then we can generate out of that Kubernetes YAMLs to run your containers in production, or generate Quadlet to run your Quadlets, Podman Quadlets on individual services. So really what we want you to do is to generate, get to the point that you're happy with the AI and then generate the orchestrated type tools for running it in Kubernetes or on edge devices with something like Podman. So what about the data? So usually when you're dealing with AI, you're just dealing with a model, but often you'll find out that the model is not very smart, so you really want to deal with some of your private data. So you want to give the model additional data. In the AI world, that's called retrieval augmented generation, or RAG. So I always call it RAG because I can never remember what those 3 words mean. But basically what this is a way to recompile your data into something that an AI model can easily interact with. In the open source world right now, there's a project called Docling, developed out of IBM Research, that RamaLama RAG will take advantage of. So Docling will take your PDFs, your Markdown, your docx files, HTML pages, and things like that, and will compile them into a format that your AI models can interact with. Right now, you'll hear things like Milvus databases and Quadrant, and there's all these different types of databases. But what we want to do is output directly into an OCI thing. So, right, we have the model in an OCI, we have your RAG data into the OCI, and then we want to connect those together. To get the AI model to work with your RAG data, it becomes just RamaLama serve -- RAG, the OCI name, and then the model. So that we will wire those together. So the last thing, the hottest thing in AI right now is a thing called agentic. And I'm waiting for the screen to show up here. Agentic is, or MCP, you might hear those terms. This is basically an AI model interacting with the real world. So it's taking random REST APIs from the internet and then allowing the AI model to actually call into them. And so that's the big hotness right now. You might look at it as being, the first step to Skynet and the Terminator. But basically, you're allowing AI to, work with, for instance, OpenShift is adding a REST API. So instead of using kube control to run AI, or to run your models, you might be able to go into a chatbot and say, how many pods do I have running in my cluster? So MCP is sort of the next step we want to get to a RamaLama. So it becomes RamaLama run maybe --MCP or --agent, and then we give an IP address, and we will wire up that all together. So the tool we're going to be using underneath the covers to do all this thing is a thing called Llama Stack. So Llama Stack is the thing Red Hat right now is investing heavily in for coordinating between models, RAG databases, MCPs. So it's basically a pipeline that we're going to be building to do that. And there is so this shows a lot more complexity of what you're able to wire together, takes all the agents, and really sets up an API service that interacts between them. There is a talk later on today at 2:45 that's going to be done by Urvashi and Sally. I heard Sally shouting it out. So you're going to see, I'm not going to be able to do a Llama Stack demo here today, but I'd advise you to go see it later on. So they will be doing a Llama Stack demo with RamaLama backend on it. And what we're trying to do is get all that slammed into a simple command that you can just run RamaLama command and generate it. And I think at this point, the last thing I'm going to talk about is the concept of multimodal. Multimodal means that you can run a single model. Most people understand you run a model and you do a chatbot with it, right? Or that's sort of the default that everybody's going to interact with. But a multimodal means you can have the AI do multiple things at the same time. So one model able to interact with AI in multiple different ways. And hopefully, at the end of this demo, we're going to put, if you saw the demo yesterday, that's basically the video stream and asking the AI to interpret what's going on in the video stream. So at this point, let's hope for the best. Live demo time. So right now, we release RamaLama on a weekly basis. We're at 0.9.1. It's not a released fully 1.0 project at this point. But basically, on a weekly basis, we update our images and we update the software. Hopefully, at a certain point, we'll slow down that release cycle. But right now, we're just trying to get it out as quickly as possible. RamaLama info will show you basically a lot of the stuff about the container engine. So this is Podman info that are injected into it, but it also shows you which GPUs are realized on your system. A lot of times, if you report a bug to us, this is one of the first things we'll ask you is to give us the output of RamaLama. They're not seeing. Oh, they're behind? Yeah. Okay. I'll try to pay more attention to this screen. So that was RamaLama info. It's basically so what I'm going to do right now is I'm actually going to remove a model. And this is the scary part because I'm actually going to pull a model. So If you do a RamaLama serve or RamaLama run, it will go out and pull a model down from the internet. Everybody get off their internet right now. It's going to take about 2 minutes. This is a fairly small model on the system. But the basic idea here is just RamaLama goes out and pull it. If you just did RamaLama run, it would do the same exact thing and download the model from the internet. A lot of people at lunchtime must have been off the internet because it came down in about 45 seconds then. But so any quick questions while I dance up here and wait for this to finish? Yes?
Can you use models that you already have on your PC that were used with RamaLama, for example?
So the question is, can you reuse models that you already pulled down with RamaLama? Not currently, but this is coming up a lot. We have a lot of people asking us to have a standardized place that VLM would store its models and we would store our models, and now Docker has storing models. And I would love to be able to do that, but I'm not going to default to RamaLama's way of storing it. So there has been talk about that. RamaLama can actually run models via the file system, so you can actually say file and point to a path. So you could, if you know where the RamaLama models are stored, you could do that. So any other questions as I continue to stall? No one else? Come on, I'm trying to stall here. I'm going to play the song if we don't, you know. I can't believe I was slow. What is it? Yep.
Can you give an example of the coolest project you personally saw so far based on RamaLama?
Can I shoot the cool, well, what is the coolest project? Yeah. What is the coolest project we've done with RamaLama? Well, we don't really interact with the AI, but I think the last thing you'll see on this with the video stream interacting with RamaLama is probably the coolest thing. Our job is just to get the models up and running, and we're working heavily with the community. Again, we have, by the way, I would like to ask everybody to go on to our RamaLama, GitHub containers RamaLama, and actually give us a like, because we're trying to get our likes up. And the interesting thing is we're getting more contributions. We're approaching over 100 contributions, and we've only been up for about 9 months. So we have lots and lots of people coming in with random pieces of crappy hardware and trying to get RamaLama and Llama CPP to work with it. But yeah, give us likes, and 11 seconds to go. 10, 9, 8, 7. This is why you don't do live streams with weak internet. There it is. Okay, so I just pulled down the model. Now I'm doing a RamaLama list. So this shows that you pull down a model from RamaLama and what its name is. You also look that these are all the images that are on the system. So this is Podman images showing out all the different, since I build on this system, the AI models, that's all the different models that we have support. Now I'm going to show you some RamaLama commands. So RamaLama has a option called dry run, which will actually show you the Podman command that we're running under the covers, or the Docker command that we're running under the covers. So you can see that this is not something you'd want to type by hand. Okay, so, but the interesting thing here is you can see I highlighted in red Podman running on the system, and that we're using Podman. And then the next one, I'm actually showing you the AI model. Since this machine, my laptop has NVIDIA, it went on and pulled down the CUDA model that we're going to be running on top of. Next thing I'm showing you is just and it'll be up there in a second, is actually the container controls we're doing. So we're dropping all capabilities on the system. We're also running it with no new privs. This internet's got to be horrendous. Okay, and when that one comes up, I'll click on the next one. So basically, so that one shows that we're dropping all privileges on the system, running with no new privs. That means that if the container engine, Llama CPP, was somehow influenced by the AI model to try to break out or grab something in your system, we've run it with basically no privilege. Everything we're doing here is running in rootless mode as well. And then the last one that's going to show up here is going to show that network equals none, which is basically saying that we're shutting down the network. So that from the container's point of view, it has no ability, even if it was able to break out and say you downloaded a AI model that wanted to create a spam bot or whatever, it would be locked down and would not see a network on the system. So I'm finally going to do a demo of and I'll do it here. And it's happening very quick, but by the time it comes up there, you're going to see it. It looks like I pre-typed it. I can't believe the network. This is the problem of going through the network to do this. But everybody shut their phones off. No. The last demo is not going to go well. Yeah. I think we're getting nothing through at this point. This is already 2 commands ago. You want to swap out yours? See if you can get it? Yeah. So we're going to do, oh, there it goes. So basically that asked who is Red Hat. We'll try, maybe we're getting better. So you can see basically it's typing, I asked the model who is Red Hat, and that's just running it locally. I think I ran Granite for that one. So now I'm going to exit out of there. And now I'm going to serve a model. And that'll be up in a second. Any other questions? Yes? Well, if you want to interact with the real world, you have to turn the network on. So the question is, if I turn off the network, how do I interact with the network or interact with services provided on the network? You have to turn it on. You've got to poke the holes in it. The bottom line is, again, if you don't trust the model, then you do that. And really, I guess what I would encourage you to do is don't trust the model. Only run trusted models on it. So here you can see the simple RamaLama serve command. So I basically did RamaLama serve port 8080. We're serving up Granite. That's, again, serving up a REST API. Then the next thing I did is to basically serve up, show that it's running containers on the system. So you can see there's RamaLama PS shows basically the output of Podman PS, shows the containers running on it. It shows that it's running RamaLama on top of the CUDA model. And in a second, you should see the Firefox showing up. Any other questions? Yes?
I don't have a question, I have a comment, because I was using RamaLama very early, and I did some contribution, and it's a lot of questions and issues on GitHub, and I thank you and all the people around it for responsiveness and for all the help. So you guys can contribute, please do, because
yeah.
these guys developing it are awesome.
We're friggin' awesome. Any other questions? Come on. Okay, so here Llama CPP. So this is just Firefox talking to the port that's being served. It actually still serves out a chatbot. And I'm going to ask it who is Dan Walsh, and we'll see what it comes up with. Any next questions? Yes?
So RamaLama provides an OpenAI endpoint. So does that mean it can plug into any of these agent frameworks when building an AI application?
Yeah, so Sally's asking a loaded question here. So since we're providing RamaLama, or actually Llama CPP is providing a OpenAI API, that means that any tool out there that can interact with OpenAI can interact with that. So there we see, told you that Dan Walsh, what he did for the industry, and you'll see, usually it has me working for IBM at some point. Anybody see anything that's wrong? Oh, I am office. I work for the office of CTO, never have. I'm a senior distinguished engineer, not just a distinguished engineer. But anyways, you get yeah. So you get some idea of that it's easy to work with. That, and I'm going to stop the service. The next one that I'm going to show is running with Llama Stack. So once that rolls over, so right now we've built in Llama Stack into the tool. The good thing is that it sort of works. The bad thing is it really doesn't work. So we're working on fixing that, hopefully by early next week. And once I go to Sally's talk this afternoon, I can figure out what I'm doing wrong. I have 5 minutes left. Any other questions? Yes?
When I use my own data with the reg command,
Yep.
where would the resulting database be stored?
It'll be stored in an OCI image. Basically, it's stored as a database file, either a Milvus database or a Quadrant database. It's stored as just a file. And then what we do is we mount it into the container image.
And the file would be the RamaLama directory structure somewhere?
It would be in a container image. So we basically store it, and you could take that container image and push it up to your private registry and then allow, so if you had a registry behind the firewall, say you were Acme Inc. Corporation, then you'd have your own private registry and you'd push it up there and now allow your services to all share that same service database. I'm going to skip ahead. So I don't have time to show right now is actually all the stuff that we do for basically Kubernetes YAMLs and things like that. So if you see it flashing on the screen, but starting to work now. That's when I start skipping ahead. Okay, so this is the grand finale. And of course, it's not going to work. Oh, I wonder if because it's not going to work because I'm going through the multiple levels. Did anybody see the keynote yesterday? They demonstrated it. We could show you how to do this on the side. But basically what you can do here is give it the camera your AI feed and be able to, what do you see, hold up different figures. We did this at Red Hat Summit, and I walked in front of the screen, and it said, I see an elderly man walking across the street. So we're working on improving the security that, it was obviously hallucinating when it saw that. But, was there another question? Yes. Yes, so right now we will generate a Kubernetes deployment out of it, and then you can take that deployment and run it inside of OpenShift. The caveat there is if you're running it on a CUDA, with a CUDA image, you have to make sure that the nodes have access to the CUDA software. So there is a little bit of heavyweight, but it'll give you a good framework to look at how you could run your images inside of Kubernetes. We also have a pull request right now to support Kserve, but we're trying to figure out how that would work, and then Quadlets for running it locally on edge devices. One of the cool things with the demo that he's trying to swap out right now is a lot of people right now, like the whole Red Hat VLM stuff is all around running a sort of a super brain, sort of the old Llama, OpenAI model, right? That we have one brain and then you have thousands of people connecting to it. So a lot of big companies are going to do that. But there's also a need for edge deployments. So edge devices, how do I run these on edge? In the demo that he's attempting to get up there right now, where we have video stream, you're not going to have 10,000 cameras sending a video stream to a centralized server and then asking the AI, right? But when I have I want to know from my camera AI if someone's coming up to drop off a box from Amazon or if someone's walking up to the door with a gun, right? I'd like to differentiate those two things. And so you could see where there's going to be a real need for edge AI. And I think some of the stuff that Llama CPP does right now for that. Is it going up?
No,
it won't share. Okay. Am I out of time? Okay. Last question. I'm out of time. One last question? Nobody? Okay, a rousing round of applause then.